Hi everyone, this video is about solving some questions in the use of cylindrical coordinate and Gauss Divergence Theorem.
Hi, my name is Nur Ada Shamir binti Ahmad Fazi. So I will tell you about the outcome of this video. The outcome of this video is to calculate the volume of solid E that has the cone that lies in the cylinder. And then we have sketched the figure of the solid E. From the question, it states that the x squared plus y squared is equals to 1, which means the x and y is equals to 1 as how we sketch on the Cartesian plane. Then we will continue with the next part. As we know, in the triple integral of the cylindrical, the x is equals to r cos theta. But in this case, the question given is x squared dv. So the x squared is equals to r squared cos squared theta. Subsequently, we have to turn the dv into a proper coordinate system, which is dv is equals to r dr dz d theta. Next, for the limit of the triple integral is from 0 until 1. This is because from the equation given is x squared plus y squared is equals to 1. The 1 means the radius. Then from the sketch that we have done, we could see that the base of the cylinder are fulfilling the Cartesian plane. So we can state that the limits are from 0 until 2 pi. Then for the last question is, the limit is from 0 until 2r. This is because from the question given is 4x squared plus 4y squared is equals to z squared. But we don't want the value of z squared, then we have to put a set on it. Then it will become 2r. And lastly, the value of 2 is also considered the height of the cylinder because of z is equals to 2 as how we sketch the figure of solid E.
So, for the calculation of finding the volume of solid E, we can solve it by integrating the r cubed cos square theta by dz, then substitute the value of 2r and 0 in the value of z. After that, we can integrate the 2r power of 4 cos square theta by dr and substitute 1 and 0 into the value of r, which is the radius. Next, integrate 2 over 5 cos square theta by d theta. In this case, we can use the trigonometric identity function of cos square theta, which is equal to 1 plus 2 cos square theta over 2. Then, integrate the function by d theta. After that, we can substitute the value of 2 pi and 0 into the value of theta. The volume of solid E is 2 pi over 5. The question can be solved.
Hi and assalamualaikum everyone. I'm Karina. Today we will learn about Gauss Divergence Theorem. Divergence Theorem says W integral surface FDS equal to triple integral W, which is solid region W divergent FdV. This theorem is similar to Green theorem, which only applies when we have a cross product. Gauss Divergence Theorem help us to transform a value integral into surface integral. W integral of surface f and ds and is a unit normal equal to triple integral of P delta V dot product of f dv. The product delta and f we will get differentiate of x, y and z. So this is one of divergent Gauss theorem application, which need verify the divergent Gauss theorem for the field x, y, z and Gauss surface as in the first order that bounded by the sphere z in the coordinate planes x, y, z equal to 0. By evaluate W integral s, f ds and the sum of the normal corresponding f over all bounding surfaces.
So before we answer the question, we rewrite back the information given as z plus yz plus z squared. And sphere, unit sphere, x squared plus y squared plus z squared equal to x squared in the first order. First order in this sphere, in this region, which is this. Okay, and then normal unit, which substitute the formula given delta sphere over minus delta sphere. We differentiate this. And then we will get 2x plus y plus 2z. Get rid this. And then we have final for n. And then we let r be the projection of integral in xy plane. dx dy. This will.
So to answer this question, we put left side is Gauss theorem, in right side is normal complementary with this. And then we multiples f, which is this, with n we get the 3 for this. And we will have 2x squared z plus y squared z and z cubed over a dx dy. Simplify in this and we will get this equation. This equation we substitute given this x squared minus y squared in substitute with this equation because we want to have in terms of x and y, dx dy. So we simplify, we will get x squared plus a squared So we change dy dx for integral inner integral y and outer integral for x. So y we have 0 and s square minus s square, and x 0 and a. And then we replace dy dx into polar coordinate, which is rd theta. It becomes rd theta. And then we need change this in spherical coordinates. We have x equal to r cos theta. So we change r s square equal to this, and then we integrate with a and a, we times with r, and we will get this value. After this, we integrate with pi over 2. Why we use pi? Because first order. This. So we pi over 2. And then, to integrate cos square theta, we use trigonometry identities. This. After we derive, and we will get a power of 4 over 8 sine 2 theta over 2 plus theta. And then, we substitute with value of pi over 2, and we will get this final answer. That's all.
Equation B, total divergence from E, the volume contained within the curved surface as the spherical coordinate for this integral. Since f equal to 2xz5 plus yzj plus 2 plus z squared k, divergence f equal to 2z plus z plus 2z equal to 5z. To integrate 5z dx dy dz. So the dz is integrated from 0 to set s square minus x square minus y square. For dy, we integrate from 0 to set s square minus x square. For dx, we integrate from 0 to a. So we integrate dz and substitute the equation. We get 5 over 2 s square minus x square minus y square, and we bring the 5 over 2 in front of the integrate sign, and we integrate dy and substitute the equation. We get bracket y over y bracket s square minus x square set s square minus x square minus s square minus x square power of 3 over 2x dx, and we simplify. We get 2 over 3 s square minus x square to power of 3 over 2 dx, and we bring the 2 over 3 in front of the integration sign, and we get 5 over 3. Integrate from 0 to a to the power of 3 minus x to the power of 3 dx, and then we let x equal to sine theta, so dx equal to cos theta d theta, and we substitute into the equation. We get 5 over 3, integrate from 0 to pi over 2, a to the power of 3 times cos to the power of 3 theta times a cos theta d theta, and we simplify the equation, and we get 5 over 3 times a to the power of 4, integrate from 0 to pi over 2 cos to the power of 4 theta d theta, and we bring the integration for d theta using integration by part, and substitute the pi over 2. We get 3 pi over 16, and times 5 over 3 a to the power of 4. For our final answer, we get a to the power of 4 5 theta over 16. By Gauss Divergence Theorem, double integrate equal to triple integral divergence f, and from part A and part B, Gauss Divergence Theorem verified. Thank you.